Tonight, we're going to follow a single line of stardust stretching across the heavens and trace it all the way to the edges of what we can know. You've seen it before, glowing faintly like spilled milk across the night sky. But that hazy ribbon holds more than just stars. It holds a paradox that will bend your sense of scale, your sense of meaning, and maybe even your place in all of this. The ancient Persians called it the river of heaven. The Maya thought it was the path of souls. To us, it is the Milky Way. But beyond the poetry, this is an actual, physical structure, a vast galactic disk filled with stars, dust, gas, and mystery, all rotating around a hidden mass we cannot see. So here's the question that will guide us tonight. How big is it, really? Not just in kilometers or in light years, but in context. Where does the Milky Way truly sit in the cosmic hierarchy? Is it a colossal structure, vast, beyond comprehension? Or is it a speck, one of countless dots floating inside something far, far greater? The truth is, both, and this duality, being both immense and insignificant, is the strange gift of cosmology. It invites us to feel small, but not meaningless, to lose ourselves in scale, but find something deeper in the process. So, before we begin, if you find comfort in these late-night journeys across time and space, and you want to join us again, consider subscribing. But no pressure. This isn't about numbers. It's about awe. Now take a breath. Dim the lights. Let's begin. Let's start close to home. The Milky Way is our galaxy. That simple sentence hides a staggering truth. You live inside a disk of stars that's roughly 100,000 light years across. A single light year is nearly 10 trillion kilometers, so we're talking about a structure more than 1,000,000,000,000 kilometers wide. That's not a metaphor. That's your cosmic address. From above, the galaxy would resemble a spiral, an elegant whirlpool of glowing arms wrapped around a dense center. We think there are somewhere between 100 billion and 400 billion stars within it. Some are enormous, short-lived blue giants that burn out in a few million years. Others are small red dwarfs that could shine for trillions. And somewhere, orbiting an ordinary yellow star about halfway out from the center, you'll find us Earth. Our solar system is nestled in a quiet spur of a spiral arm called the Orion Arm. It's not a glamorous address. We're not in the bustling galactic core. We're in the suburbs, floating through a peaceful neighborhood of stars. But that's probably a good thing. The galactic center is dangerous. It's densely packed, chaotic, irradiated. Near the core lies Sagittarius A star, the supermassive black hole around which the entire galaxy rotates. Its mass is more than 4 million times that of our Sunday. Here, far from that heart, we orbit in peace. But here's where it gets interesting. Despite how enormous it feels, the millions of suns, the 100,000 light-year span the Milky Way, is not considered unusually large in the grand cosmic census. In fact, most galaxies are much, much smaller. Astronomers call them dwarf galaxies. They're the most common type in the universe. Some are barely a few thousand light-years across, home to only a few billion stars. They're scrappy, irregular in shape, and they orbit around larger galaxies like satellites. In our own cosmic backyard, we can see them. The Large and Small Magellanic Clouds are two dwarf galaxies visible from the southern hemisphere. They're gravitationally bound to us, and over time, they may merge with the Milky Way. So, in a sense, our galaxy is already consuming others, growing over time, devouring neighbors, becoming more massive. And yet, among the giants, we're not the largest. Far beyond us lies IC 1101, once considered the biggest known galaxy. Its diameter may reach over 6 million light-years. If you placed the Milky Way next to it, we'd be the size of a penny next to a large pizza. And then there's a 2261 BCG, a massive elliptical galaxy in a dense cluster, even larger, with a mysterious core that may contain not one, but multiple black holes. So where does that leave us? Not tiny, not average, but not the biggest either. perhaps a moderately massive spiral galaxy, which is astronomers speak for bigger than most, smaller than some, beautiful in its own right. But size alone doesn't tell the full story. The real question, the one that haunts astronomers and poets alike, is what role does our galaxy play in the larger structure of the universe? And to answer that, we have to zoom out. First, let's look at the neighborhood. The Milky Way is part of a small gathering of galaxies called the Local Group, about 50 or so members, the biggest of which are us and the Andromeda Galaxy. Andromeda is slightly more massive and is currently on a slow-motion collision course with the Milky Way. In 4 billion years, give or take, the two will merge into a new galaxy, perhaps Milkdromeda, as some affectionately call it. Beyond that lies the Virgo supercluster, a larger region of space containing thousands of galaxies. It's a part of an even greater structure, Laniakea, meaning immense heaven in Hawaiian, a vast web of galaxy clusters connected by gravity. So now, the Milky Way becomes less like a city and more like a house in a suburb, in a state, in a continent of galaxies. Every time we zoom out, our sense of proportion shifts again. And here's the most mind-bending part. The universe seems to be structured like a web. Galaxies cluster along vast filaments, separated by enormous voids, regions of space so empty they defy belief. The largest of these voids, the KBC void, spans nearly 2 billion light-years. That's a hole in space big enough to swallow thousands of Milky Ways and still have room left over. So now imagine your galaxy, filled with hundreds of billions of stars, is just one glowing point, one tiny node in this vast lattice. The more we understand, the more the Milky Way begins to feel like a single light on a Christmas tree. Beautiful, yes, but not unique. And yet, it's home. And for all its swirling chaos, for all its collisions and mergers and radiation storms, somehow, here, in this quiet corner of a spiral galaxy, life arose. And that's where we'll go next. But for now, look up. That band of light you see, soft, silver, ancient, it's more than dust and stars. It's your address in the cosmos. It's the stage for your entire existence. And it's only the beginning. To truly understand the Milky Way, to grasp what it is and what it means, we have to travel back. Not just to the beginning of our galaxy, or even to the beginning of stars. We have to go to the very edge of time itself. Let's begin with the beginning. Roughly 13.8 billion years ago, the universe exploded into existence. That's the Big Bang, not an explosion in space, but of space. Time itself unfurled, and with it came energy, matter, and the fundamental laws that would one day allow galaxies and people to exist. In the first trillionth of a second, the universe expanded faster than the speed of light. This is known as cosmic inflation, and it smoothed out the chaos, leaving behind tiny irregularities, fluctuations in density that were random, quantum whispers, frozen into the fabric of reality. Those ripples? They're everything, because as the universe expanded and cooled, these slight variations, some patches just a little denser than others, became gravitational wells. Over hundreds of millions of years, matter flowed toward these wells. The denser areas gathered more and more mass. Eventually, clouds of hydrogen and helium collapsed to form the very first stars. They were nothing like the stars we know today. These were the firstborn, massive, short-lived titans made entirely of pristine hydrogen and helium. They lived fast, burned bright, and died young, often in violent supernovae that scattered heavier elements across space. Those elements, carbon, oxygen, iron, didn't exist before. They were forged in the hearts of those first stars, and in their death throes, they seeded the cosmos with the building blocks of planets, of life, of you. Now imagine, the universe was still dark then. The cosmic background radiation had faded into infrared. There were no galaxies yet, just scattered halos of matter collapsing into themselves. Over time, those halos merged, sometimes gently, often violently, forming the first proto-galaxies. And in one corner of the expanding cosmos, something beautiful began to take shape. The Milky Way was not born fully formed. It was built, layer by layer, from the wreckage of earlier structures. Dwarf galaxies collided and fused. Streams of stars were torn apart by gravity. Over billions of years, a disk began to form a stable, rotating spiral of stars and gas. That's the structure we call home. Even now, we can see the fingerprints of those ancient mergers. The halo of our galaxy, an extended, spherical cloud of old stars, holds remnants of galaxies that the Milky Way consumed long ago. Some streams of stars still trace the arcs of their doomed orbits, ghosts of cosmic cannibalism. This is what astronomers call galactic archaeology. By studying the motion and chemical composition of stars, they can reconstruct the Milky Way's past. It's like sifting through the ruins of a forgotten city, except the ruins are light years across and the buildings are stars. It turns out our galaxy is still growing. New dwarf galaxies continue to fall into the Milky Way. In fact, one is doing so right now, the Sagittarius dwarf galaxy. It's being pulled apart as we speak, its stars stretched into elongated streams. In a few billion years, its remnants will become part of our own stellar population. We are a dynamic, living system, not a static object. And we're not alone in this dance. The Milky Way exists in a small collection of galaxies called the Local Group. It's a gravitationally bound family of about 50 galaxies, though most are dwarfs. The two largest are us and the Andromeda galaxy. Andromeda is slightly bigger and more massive than the Milky Way. It's also heading toward us at a speed of roughly 110 kilometers per second. That sounds fast, but in cosmic terms, it's a slow waltz. The collision is expected in about 4 billion years. When it happens, the result won't be an explosion. Stars are so far apart that very few will collide. Instead, their gravitational fields will tangle, twist, and reshape both galaxies. Over the course of another few billion years, the chaos will settle into a new galaxy, a giant elliptical structure that some astronomers jokingly call Milkdromeda or Milkomeda. It's hard to imagine the night sky of future Earth. If Earth still exists then, the stars of Andromeda will grow larger and brighter over millennia, merging with our own to form a glowing canopy of merged constellations. But even this future isn't the end of the story, because the Local Group itself is just one of many clusters of galaxies. Ours lies near the edge of the Virgo cluster, which contains thousands of galaxies and spans about 100 million light-years. Both our Local Group and the Virgo cluster are part of a larger supercluster called Laniakea, meaning immense heaven. This supercluster, in turn, is part of an even more vast network, the cosmic web. When you map the universe on the largest scales, galaxies are not distributed randomly. They form a filamentary structure, a vast spiderweb of matter and void. The threads of this web are made of clusters and superclusters. The gaps in between the voids are unimaginably empty, spanning hundreds of millions of light-years with hardly a galaxy in sight. And here, hanging delicately on one of those threads, is the Milky Way, one galaxy, orbiting a black hole, made from the wreckage of smaller galaxies, woven into a cosmic web so vast, we still don't know where it ends or if it ends. So how did we get here? From quantum ripples in the early universe, to the collapse of primordial clouds, to the mergers of ancient dwarf galaxies, to the slow, stately rotation of a spiral disk of stars. We are the product of billions of years of cosmic evolution, and it's not over. Stars continue to be born in the Milky Way, roughly one every few years. Dust and gas swirl in giant molecular clouds, collapsing under gravity, igniting fusion, bringing new light into the galaxy. Somewhere, perhaps even now, a star is being born that will one day host a planet like Earth, maybe even life, and that's where we'll go next. Because when you look up, you're not just seeing stars, you're seeing history, and you're a part of it. Imagine you're standing outside, far from the lights of the city. It's quiet, just the rhythm of your breath and the distant hum of crickets. You tilt your head up, there it is, that pale arc stretching across the night sky. You're not just looking at stars, you're looking at the cross-section of your own galaxy from the inside. The Milky Way is a flat spiral, like a dinner plate made of fire and gravity. From our position, buried in one of its outer arms, we see the plane of the disk edge on. That's why it appears as a faint band across the sky, a band composed of hundreds of billions of stars, seen through clouds of gas and dust that blur and darken the view. It's easy to forget how much is hidden in that band, not just distant stars, but entire star clusters, nebulae, and maybe even civilizations, still undiscovered. We orbit this galaxy, not metaphorically, not in a poetic sense, but literally like a marble caught in a slow, enormous current. Our solar system is about 27,000 light years from the galactic center. At our current speed, roughly 220 kilometers per second, it takes about 230 million years to make a full orbit. Think about that. One galactic year ago, dinosaurs were just beginning their reign. We've only existed as a species for a few cosmic heartbeats. Your whole life is a flicker in the blink of this one orbit. And yet, in that flicker, we have come to know what we are part of. That knowledge is both humbling and electric. Let's look at the spiral. The Milky Way is not a perfect swirl. It's made of multiple spiral arms, each a region of increased density, like traffic jams of stars. These arms are not rigid, they're waves, rippling through the galactic disk, triggering star formation as they go. Our Sun sits in a small spur between two of the major arms, the Perseus arm and the Sagittarius arm. This little region is called the Orion Spur, and it's our home. The stars you see at night, Vega, Sirius, Betelgeuse, Procyon, they're all local, a few dozen light years away at most. The Sun's neighborhood, in the galactic sense, is relatively quiet. No nearby supernovae, no roaming black holes. That calm is what allowed life to evolve in peace. We often imagine our planet as small, but in reality, Earth exists in an unusually safe and stable galactic zone. Astronomers even have a term for it, the galactic habitable zone, a region not too close to the center, where radiation is deadly, and not too far out, where heavier elements are scarce. Earth lives in the sweet spot. That's no guarantee of permanence. But it does explain why, in this immense and often violent universe, something as delicate as consciousness could emerge. But we are not static passengers. The galaxy is moving beneath us. The stars in the Milky Way orbit the center, but not in neat, predictable paths. The entire disk wobbles slightly, like a spinning plate on the edge of falling. The arms shift. The core itself may be rotating in a slightly different plane than the outer disk. Even the dark matter halo, a spherical cloud of invisible mass that envelops the whole structure, is not entirely symmetric. Over cosmic time, the galaxy breathes. It inhales matter. It exhales energy. It twists and warps. And somehow, we hold on. We hold on to the idea that we are part of something greater, because you are orbiting the center of a galaxy. That galaxy is orbiting within a group of galaxies. That group is part of a cluster. That cluster is caught in the flow of a supercluster. And that supercluster is one thread in the cosmic web. All of that motion, all of that structure, and still here you are, sitting, breathing, thinking. But here's a strange thing. Even though we live in this galaxy, we can't see it all. The dust in the galactic plane blocks much of our view. We have to use radio waves, infrared, X-rays tools that see what our eyes cannot. Even then, mapping our own galaxy is like trying to chart a forest while standing deep inside it. We estimate the number of stars, the shape of the arms, the location of the core based on light echoes and star velocities, and subtle patterns in the data. It's like building a mirror image of your own home, blindfolded. Still, we've learned astonishing things. We know that the Milky Way has a bar-shaped core, an elongated region of older stars that stretches across the center. We know it has at least two major arms, possibly four. We know that star formation is ongoing, especially in places like the Orion Nebula. And we know that everything we can see, every star, every planet, every cloud, is only a small fraction of the total mass. Most of the galaxy is made of something we cannot see, dark matter. It does not glow, it does not absorb light, but its gravity bends the motion of stars. It holds the galaxy together. Without it, the Milky Way would fly apart. This invisible scaffold shapes everything we are. Think about that. The stars, we see the ones that twinkle above us, are just decorations on a framework we don't fully understand. There's something oddly comforting in that mystery. Something that says we are still learning, still reaching, still building a picture of home. So, what do we do with this knowledge? What does it mean to orbit a spiral galaxy on a pale blue world, halfway between the core and the void? It means we are rare, not in a prideful sense, but in a grateful one. It means we are survivors, products of a galactic environment that allowed, somehow, the improbable chain of events that led to memory, to curiosity, to questions like these. It means that when you look up on a clear night, under that glowing ribbon, you are seeing a part of yourself. The atoms in your body were forged in that disk. The elements of your mind once flowed through ancient stars. You are not just in the Milky Way, you are of it. And so, the next time you feel small, remember, you are part of a spiral 100,000 light years across, orbiting a core 4 million times the mass of the Sunday, held together by invisible threads of gravity and time. And yet, somehow, you get to ask why. What lies beyond the Milky Way? How many galaxies are there? How do we even know? We'll zoom out again, this time beyond our local group, and walk the ladder of cosmic structure, clusters, superclusters, walls, and filaments, all the way to the edge of the observable universe. But for now, sleep well. You're spiraling through the stars, and you belong here. So far, we've walked the spiral arms of the Milky Way. We've drifted through its history, its motion, its quiet corner of space where life had the rare chance to breathe. But now it's time to take a step back farther than we've ever gone before, because the Milky Way is not alone. It's not even the biggest thing in its neighborhood. It's just the first page in a vast, unfolding structure that makes the mind tremble. Let's climb the cosmic ladder. We begin with our local group. That's the gravitational family we belong to. It includes the Milky Way, Andromeda, the Triangulum Galaxy, and a swarm of dwarf galaxies like the Large and Small Magellanic Clouds. In total, there are more than 50 members, but only a few are major players. The Milky Way and Andromeda dominate the scene, and the two are on a slow, inevitable collision course. We've mentioned this before, but here's something new. As they spiral toward each other, their combined gravity anchors the group. Everything else, every dwarf galaxy, every floating cloud of hydrogen moves in relation to that core tension. Now, zoom out. The local group is part of a much larger community, the Virgo supercluster. The Virgo supercluster contains thousands of galaxies spread across a region about 110 million light years wide. If the local group is a town, Virgo is the state it belongs to. At its heart lies the Virgo cluster, a dense region of space filled with more than 1,000 galaxies, all bound together in a complex gravitational ballet. Most of these are elliptical galaxies, giants shaped more like orbs than spirals. The Milky Way is not in the Virgo cluster. We're orbiting its outskirts in a loosely bound association, but we are part of its flow. Our galaxy, like a leaf in a current, is drifting slowly toward this massive gravitational center. But the ladder doesn't stop there. The Virgo supercluster itself is part of a yet larger structure, one that has only recently come into focus. It's called Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea is not just a cluster or a collection. It's a gravitational basin, a flow of galaxies moving together, shaped by the surrounding mass of the universe. Think of it like a valley. Galaxies are rolling down its slopes, pulled toward an unseen center. That center is known as the Great Attractor, a mysterious gravitational anomaly located hundreds of millions of light years away. We can't see it directly. It lies behind the zone of avoidance, a region obscured by our own galaxy's dust, but we can feel its pull. Everything in Laniakea, more than 100,000 galaxies, is slowly drifting toward the Great Attractor, like debris in a vast, cosmic whirlpool. And here's where the scale starts to break our minds. Because Laniakea is not alone. Just as galaxies form groups, and groups form clusters, and clusters form superclusters. Those superclusters connect into walls, massive sheets of galaxies, stretching across billions of light years. Yes, billions. Take the Sloan Great Wall. It's one of the largest known structures in the observable universe, about 1.3 billion light years long. Then there's the CFA2 Great Wall, the Boss Great Wall, and the most extreme of all, the Hercules Corona Borealis Great Wall, which may extend over 10 billion light years. That's so large, it almost defies the cosmological principle, the idea that the universe should be roughly the same in all directions on large scales. These structures challenge that assumption. They whisper of something deeper, a hidden order beneath the apparent randomness, a map we don't yet understand. Now picture this: these walls, clusters, and filaments are not randomly scattered. They're strung together in a cosmic web, a sprawling three-dimensional lattice of galaxies, with vast voids in between. Voids are the silent spaces of the universe, stretches of emptiness that span hundreds of millions of light years with almost nothing inside. The largest known void, the KBC void, is more than 2 billion light years across. That's 2,000 times the diameter of the Milky Way, and we may be inside it. Yes, our galaxy appears to sit on the edge of this enormous void. That could help explain certain anomalies in cosmic background radiation, in galaxy distribution, even in the apparent acceleration of the universe's expansion. Imagine that. Our entire observable universe, a sphere roughly 93 billion light-years wide, may be shaped in part by the place we occupy in a vast pocket of nothing. At this scale, even the idea of a location starts to unravel. We're no longer talking about coordinates. We're talking about flows, the direction galaxies move, the subtle warping of space caused by concentrations of mass. The universe is not static. It's a living thing, breathing through gravity. And what holds it all together? Dark matter and dark energy. Dark matter forms the skeleton. It's the hidden scaffolding that gives shape to the cosmic web. It binds galaxies into clusters, and clusters into walls. We can't see it, but we know it's there because of how galaxies move. The stars are simply decorations on a much darker frame. And then there's dark energy. That's what's pulling the web apart. It causes the universe to expand not just steadily, but accelerating. Every second, space itself stretches. Galaxies not gravitationally bound to us are slipping away faster and faster. Beyond a certain distance, they're receding faster than light itself, not because they're moving through space, but because space is expanding between us. That means one day far in the future, the night sky will grow quiet. The stars of other galaxies will fade. The walls will dissolve beyond our view. Eventually, even the closest galaxies will drift over the horizon of what we can observe. And then, we will be alone. But we are not there yet. Right now, you live at a rare moment in cosmic history, a time when the universe is still connected, still visible. You can look through a telescope and see galaxies as they were billions of years ago. You can measure their redshift, trace their flow, sketch the outlines of this impossible web. You are part of a species that climbed down from trees, built radio dishes, aimed them at the sky, and found walls of galaxies stretching to infinity, and in doing so, found humility. We do not live at the center of anything, not of the galaxy, not of the local group, not of the supercluster. We are not even at the center of the observable universe because there is no center. Every point expands equally. Every galaxy sees the others receding. It's not that we're special, it's that we're inside a miracle that plays no favorites. But for now, let the scale settle in. You are orbiting a galaxy, inside a group, inside a supercluster, sliding down the slope of an unseen gravitational tide, strung like a pearl on a filament that threads across eternity. Sleep well, traveler. You are woven into something vast, and it's still unfolding. By now, we've wandered far, from the quiet spirals of our home galaxy to the web of walls and voids that stretch across the known universe. We've spoken of stars, of clusters, of cosmic flows and gravitational tides. But there's something we've been moving through this whole time without fully addressing, something unseen, something that does not shine. Tonight, we turn to the invisible skeleton of the cosmos. Because everything we've talked about, the galaxies, the stars, the luminous parts, is only a fraction of what's really there. In fact, all the matter you've ever known, planets, stars, gas, even you, makes up less than 5% of the total mass energy of the universe. The rest? It's made of mysteries. Let's begin with dark matter. The term sounds dramatic, like something from science fiction, but it's real and we know it's there, not because we can see it, but because of what it does. In the early 20th century, astronomers began noticing something strange. Galaxies were spinning too fast. Based on the amount of visible matter, the stars on the outer edges should have been flung away like stones from a spinning wheel. But they weren't. They held on. Something unseen was keeping them tethered. That something is dark matter. It doesn't emit light. It doesn't absorb it. It doesn't interact with electromagnetic radiation at all. But its gravitational fingerprint is unmistakable. It surrounds galaxies in vast, spherical halos, extending far beyond the visible stars. It binds galaxy clusters together, shaping their motion. And on the largest scales, it forms the cosmic web itself. Those vast filaments of matter we spoke of earlier are built on a framework of dark matter. Imagine painting a sculpture you can't touch. You don't know its exact shape, but you can see how the paint pools and drips. That's how we know dark matter is there. The luminous galaxies are like paint running down invisible structures. So what is it? We don't know. That's the honest answer. Dark matter remains one of the biggest unsolved puzzles in physics. We know it's not made of atoms, at least, not the kind that make up you and me. It doesn't fit into the standard model of particle physics. It doesn't seem to clump or collide like ordinary matter. The leading candidates are particles called WIMPs, weakly interacting massive particles, or perhaps axions, or some other exotic field yet to be discovered. Entire labs are built to detect them, underground detectors buried beneath mountains, shielded from cosmic rays, waiting for a single whisper of interaction. So far, we've heard nothing. But absence of detection is not absence of existence. Like wind through the trees, dark matter reveals itself through motion, not through light. And it is everywhere. There's likely more dark matter passing through your body every second than atoms in the air you breathe. It's not dangerous. It's just indifferent, a quiet participant in the drama of existence. And then there's dark energy. If dark matter binds, dark energy drives apart. It is the force responsible for the accelerating expansion of the universe. Not only is space expanding, it's speeding up. This discovery, made in the late 1990s by observing distant supernovae, stunned physicists. It earned a Nobel Prize, because until then, we believed gravity would slow expansion, perhaps even reverse it. Instead, we found the opposite. Galaxies not bound to us are racing away faster and faster, carried on a tide of growing space. So, what exactly is dark energy? Again, we don't know. It may be a property of space itself, a kind of vacuum energy built into the fabric of space-time. It could be a new field or a flaw in our understanding of gravity. What we do know is this. It accounts for roughly 68% of the total energy in the universe. Think about that. Almost 7/10 of reality is something we can't detect directly, can't isolate, can't bottle or bounce off a detector. But we can measure its effects with exquisite precision. The cosmic microwave background, the afterglow of the Big Bang, carries tiny fluctuations that reveal the fingerprints of dark energy. Large-scale surveys of galaxies trace how structures grew over time, slowed by dark matter, accelerated by dark energy. It's as if the universe is being stretched by something it carries within itself, like a balloon inflating not because of air being blown in, but because the rubber wants to expand. And as that balloon grows, more space is created, more dark energy appears. Expansion begets expansion. This feedback loop leads to a chilling idea, the far future of cosmic loneliness. If dark energy continues as it is, or accelerates further, then in tens of billions of years, every galaxy, not gravitationally bound to us, will pass beyond the cosmic event horizon. That horizon is not like the edge of a planet, or the boundary of a solar system. It's more like a point of no return. Beyond it, light from distant objects will never reach us, not because it's blocked, but because space is stretching faster than light can cross it. Eventually, the night sky will go dark. All the galaxies we can now see, the thousands caught in Hubble's lens, will vanish. The cosmic web will thin to a single strand, the remains of the local group, bound together by gravity. The Milky Way and Andromeda will have long since merged into a giant elliptical galaxy. The stars will grow old, star formation will slow, and from that point forward, all the wonders we now explore, the walls, the filaments, the accelerating universe, will be lost to future observers. They will look into the night and see only their own galaxy, and they may never know there was more. Unless we remember, unless we pass this knowledge forward through story, through science, through some future archive, riding on a beam of light, this perspective could be lost. The future may need our curiosity to survive its darkness, because what we've discovered is precious. That we live in a moment when we can see the universe, that we've built instruments that can trace the invisible, that we've uncovered the outlines of forces that shaped everything from the Milky Way to you. And though 95% of the cosmos is unknown, it is not unknowable. We are still learning, still asking, still orbiting mysteries too vast to hold and too beautiful to ignore. Because it's one thing to orbit a star in a galaxy, it's another to do so on a planet where oceans shimmer, trees breathe, and something dares to wonder. Why? Sleep softly. You're surrounded by silence, wrapped in invisible threads, and still so full of light. Let's return home. We've floated through the dark architecture of the universe, through halos of unseen matter and winds of accelerating space. But now we descend, back to our corner of the spiral, back to the quiet suburbs of the Milky Way, back to a single star and the thin blue thread that dances around it. And here's the question: how rare is all this? The Earth, the solar system, the precise balance of chaos and calm that allowed life not just to exist, but to endure. Is this normal, or is it exceptional? The answer is complicated. Let's begin with what we know. The Milky Way is a spiral galaxy moderately large, home to somewhere between 100 billion and 400 billion stars. That's an enormous range, but cosmic bookkeeping is tricky. Most of those stars are red dwarfs, cool, dim, long-lived. Some are yellow suns like ours. Fewer are blue giants, short-lived and ferocious. Each star may host planets. Some host many. Astronomers now believe there are likely more planets than stars in the Milky Way. That means hundreds of billions of worlds, possibly even trillions, and not just gas giants and frozen wastelands. Thanks to missions like Kepler and TESS, we've discovered that rocky, Earth-sized planets in the habitable zone where liquid water can exist are not rare. They are common. Let that settle in for a moment. We once thought Earth might be a miracle. Now we know planets like Earth may number in the billions in this galaxy alone. Worlds with oceans, clouds, seasons. Worlds where the ingredients for life, carbon, nitrogen, oxygen, are scattered like seeds in the soil. And yet, we have found no one else, no signal, no shimmering beacon across the stars, no sign of cities glittering in the void, no whisper in the cosmic silence. This is the Fermi paradox, named after the physicist Enrico Fermi. It poses a simple question. If the universe is so big and life is not rare, where is everybody? Let's explore some possibilities. First, time. Our galaxy is over 13 billion years old. Civilizations may have risen and fallen long before Earth even formed. We could be late to the party, or early, or perhaps intelligence is common, but long-lasting civilizations are rare. A species might build radios, discover physics, and then destroy itself, or choose not to speak, or simply evolve into something unrecognizable. Second, distance. Even if intelligent life exists, they may be too far to detect. Light takes years, hundreds, thousands, even millions to cross from star to star. Civilizations may be winking in and out of existence like fireflies in a fog, never overlapping, never catching a glimpse of each other. Third, rarity. Maybe the conditions for complex life are rare, not just water, but a stable atmosphere, a magnetic field, plate tectonics, a large moon to stabilize the axial tilt, a quiet star, a location far from supernovae. Earth may lie in a rare cosmic Goldilocks zone, not just around a star, but inside the galaxy itself. Remember, we orbit in the Orion Spur, not too close to the galactic center, where radiation is lethal, not too far into the outer rim, where heavier elements are scarce. We are in the quiet zone, the fertile valley. Perhaps that's uncommon. There's another idea, the Great Filter. It suggests that somewhere along the chain, from life to intelligence to technology to galactic civilization, there is a step that is nearly impossible to cross. If the filter lies behind us, it means we are rare survivors, one of the very few to have made it this far. If it lies ahead, it means we may be approaching a barrier we cannot pass. Neither option is comfortable. One implies cosmic solitude, the other implies imminent collapse. But maybe the silence is not a warning. Maybe it's an invitation. Because here's something else we know. This Earth, this place, is alive. Not just with biology, but with meaning. It holds memory, imagination, empathy. It sings in a voice no other planet, as far as we know, has ever sung. That is not nothing. And the more we learn about the universe, the more we begin to see just how strange this planet really is. We have plate tectonics, a geologic recycling system that refreshes continents, balances carbon, and keeps temperatures stable. We have a large moon stabilizing our axis, moderating tides, allowing for complex oceanic life. We have just the right amount of water, not too little like Mars, not too much like Europa. We orbit a stable, middle-aged star, not prone to sudden flares, and we have a magnetic field shielding us from cosmic radiation. All of this, together, it may be rare, or maybe not, we still don't know. But until we do, Earth remains the only place in the universe where consciousness as we know it has bloomed, and that is worth protecting. So, is the Milky Way special? Yes and no. Among galaxies, it's large, but not the largest. Beautiful, but not unique. But it contains this: one pale blue dot, one atmosphere wrapped around an ocean, one set of conditions that gave rise to stories, music, grief, love, wonder, and that makes it sacred. Not in a mystical sense, but in a statistical one, because rarity is sacred. So when you look up at the Milky Way tonight, if the sky is dark enough and your eyes have adjusted, remember this. That soft arc of light is a cross-section of your home, one among hundreds of billions. And somewhere in there, orbiting an unremarkable star, on an unremarkable spiral arm, is something utterly remarkable. You, the only known fragment of the universe that looks up and asks where it came from, that listens into the dark for company, that wonders, not just how, but why. And perhaps that is the rarest thing of all. What does it mean to see light from a galaxy 13 billion years old? Why does looking deeper into space mean looking backward in time? And what happens when the lights finally go out? For now, sleep softly. You are rare, not because you are the center of the universe, but because you are not, and yet you still shine. Tonight, let's shift perspective, not in space, but in time, because the farther we look, the farther back we go, literally. In astronomy, telescopes are not time machines by metaphor. They are time machines, in fact. Here's the key truth. Light moves at a speed, roughly 300,000 kilometers per second. That's fast, but not instant. When you look at the moon, you're seeing it as it was 1 second ago. The sun, roughly 8 minutes ago. Saturn's rings, over an hour ago. Andromeda, 2.5 million years. So when you peer deeper into space, you're not just mapping distance, you're unrolling history. The stars you see at night, some are already gone, their light is just arriving. The galaxies caught in the Hubble Deep Field, you're seeing them as they were when Earth was still molten rock. This is what makes astronomy different from every other science. We are not observing things as they are. We are observing things as they were. Let's go deeper. The oldest light we can see is the cosmic microwave background, the afterglow of the Big Bang. It's been traveling toward us for over 13 billion years. This light was released when the universe cooled enough for atoms to form, making space transparent for the first time. Before that, the universe was a hot, glowing fog opaque, like the surface of the Sunday. We can't see beyond that glow. Not with light. It is the horizon of the observable universe. Not because the universe ends there, but because light from beyond hasn't had time to reach us. That means the edge of visibility is not a wall. It's a clock. But here's the twist. The universe has been expanding all this time. So even though the light began its journey over 13 billion years ago, the space it traveled through has stretched. That's why the observable universe isn't just 13 billion light years wide. It's more than 93 billion light years across. Space doesn't just sit still while light travels. It grows. This is one of the deepest truths of modern cosmology and one of the hardest to grasp. Distance and time are not separate. They bend together. The farther you look, the older the light and the more stretched the space. So, when we see a galaxy 10 billion light years away, we're not just seeing something far, we're seeing something ancient, a flicker from a time when stars were just beginning to gather into spirals and ellipses, when the heavy elements were still rare, when the building blocks of planets and life were just beginning to form. But the telescope does more than show us what was. It reveals what will never be again. Some of the galaxies we observe are already gone, swallowed by mergers, faded into dust, or moved so far away that no future light will ever reach us. In other words, some of what we see in the night sky, we see for the last time. There's something heartbreakingly beautiful about that. It means that the light reaching your eyes tonight might be the last echo of a thing that once burned, and now is silent. You are the final witness. And here's another paradox. As the universe expands faster and faster, more galaxies are being pushed beyond our cosmic event horizon. That's the boundary beyond which space is stretching faster than light can bridge. It's not a wall you can touch. It's a moving line, a point of no return. Galaxies beyond it still exist, but their light will never reach us again. They are becoming unobservable, invisible, not because they faded, but because space itself carried them too far, too fast. Eventually, only the local group will remain visible. Every other galaxy will disappear into the dark. The sky will go still, not because the universe stopped, but because our window closed. Now imagine a future astronomer, billions of years from now, looking up at a sky empty of all but a handful of nearby stars. No cosmic microwave background, no evidence of expansion, no signs that there ever was a larger universe. To them, the cosmos will appear static, quiet, finite, unless they discover our records, our maps, our telescopes, our whispers into space. They may never know how vast the universe once appeared. They may never know the truth we now hold, that we live in a rare moment, a brief window when the universe is visible, when the light from the beginning still washes over us, when the galaxies still speak, if only in silence. And that's why these nights matter, because when you look up at the Milky Way, or through a telescope at a galaxy 10 billion light years away, you're not just looking out, you're looking back. And in a way, you're looking back to the birth of stars, back to the formation of galaxies, back to the moment when the universe first began to remember itself. And here you are, made of stardust, seeing stars, asking what they remember. There is a kind of time only the cosmos knows, measured not in minutes, but in the journeys of photons, measured in light years, and redshifts, and gravitational waves, measured in the quiet between two heartbeats as you look up and feel the pull of something older than life. You are a moment within moments, a node in time's unfolding web, and your presence matters because you are here at the one moment in history when the universe can be known, not fully, not perfectly, but meaningfully. You are the consciousness at the end of an ancient beam of light, and that is something no galaxy, no cluster, no dark matter halo can replicate. What will happen when the stars go dark? When the spiral slows? When the universe grows cold? The story does not end with now, but for tonight, rest gently. You are watching the past, living the present, and reaching toward eternity. The stars are not forever. They feel eternal, tiny, unwavering points in the sky, patient and indifferent. But they are not timeless. They are burning, transforming, spending themselves. And that means the night sky we see now glimmering with energy and pattern is temporary. So tonight, let us drift forward, past our moment, past the age of Earth, past the merging of galaxies, the quieting of clusters, the fading of light. Let's explore the long future of the Milky Way, the long future of the cosmos. We begin a few billion years from now. The Milky Way and the Andromeda Galaxy, currently approaching one another at about 110 kilometers per second, will collide, not in a fiery crash, but in a slow, gravitational waltz. Despite containing hundreds of billions of stars each, the space between stars is so vast that most will pass by one another. It's like throwing two swarms of bees together, dense, dynamic, but rarely touching. Over the course of a few billion years, the two galaxies will twist and pull at each other. Long tails of stars will be flung into space. Cores will merge. The graceful spiral arms will distort into chaos. And what remains? A single, massive, elliptical galaxy rounder, redder, quieter. Astronomers call this future merger Milkdromeda, or sometimes Milkomeda. The Milky Way as we know it will be gone, but the stars will still shine. For a while, fast forward hundreds of billions of years, star formation has slowed dramatically. That's because galaxies are powered by gas-cold molecular clouds that collapse under gravity to form new suns. But over time, that gas gets used up, ejected by supernovae, heated by black holes, blown out into intergalactic space. Eventually, the fuel runs dry. The final generations of stars are born small red dwarfs, efficient and faint, capable of burning for trillions of years. But even they, one by one, will fade. The bright, hot stars die first, then the average ones like our Sunday, and slowly, the dwarfs, until only cold remnants remain. White dwarfs, neutron stars, black holes. The night will grow quieter. Not darker, because darkness implies contrast, but emptier. And then the universe enters what some call the degenerate era. It is not poetic, it is mathematical. No more new stars, just the leftovers. White dwarfs will cool into black dwarfs, objects made of matter, but radiating no light, invisible unless disturbed. Neutron stars will drift in silence, spinning ever more slowly, and black holes will wait. They are patient beyond measure. Black holes are the final actors in this future play, over unimaginable timescales longer than the current age of the universe. By factors of trillions, black holes will dominate. Their gravitational pull will draw in whatever remains, stars, gas, light, even other black holes. But black holes are not truly eternal either. According to quantum theory, they emit a faint radiation, Hawking radiation, caused by quantum fluctuations near their event horizons. Over time, they evaporate. A stellar mass black hole might take 10 to the power of 67 years to vanish. A supermassive black hole, like the one at the center of the Milky Way, could take 10 to the power of 100 years or more. But given enough time, even they will disappear. And then, silence. The universe will be vast, cold, empty, filled only with subatomic particles drifting across ever-expanding space. Entropy will have reached its maximum. There will be no usable energy left to do work. No stars, no heat, no memory. This is known as the heat death of the universe. Not a fire, but a fading. Not a bang, but an endless sigh. Time will still move forward, but nothing will happen. A trillion years will pass in the same stillness as a single second, and no one will know. It's a bleak picture, but not a hopeless one, because meaning is not found in how things end. It is found in how things are and how they're witnessed. The stars are not less beautiful because they will die. They are more beautiful because they won't last. And the fact that we live now during this brief cosmic window when stars shine and galaxies sparkle and light still flows between the filaments that is a gift. You were born in the stellar era, the age of light. You are made of atoms forged in supernovae. You think with a brain powered by a sun that will one day fade. You live on a planet where warmth and complexity have intersected for just the right span of time. You are a flare in the darkness, a voice in the silence, and that matters. So what do we do with this knowledge? We remember it, we share it, we carry it forward. We build instruments that capture light from galaxies billions of light years away. We write songs. We teach our children to wonder. We look up, because even if the stars go out, even if the galaxies drift beyond reach, even if black holes someday exhale into nothing, there was a time when the universe knew itself, when it told stories about its birth, when it made minds that could see beauty in entropy. And that time is now. How should we live, knowing all this? Does it make our daily struggles feel smaller or more sacred? And how do we find purpose when everything we know is temporary? Until then, let the stars above be your reminder. They are dying, yes, but they are not dead yet, and neither are you. Sleep gently. You are a child of light, living at the edge of forever. You've now seen the vast machinery of the cosmos, galaxies colliding, stars forming and fading, time stretching across trillions of years. You've stood at the edge of the observable universe, and then walked past it into the silence that awaits. So now, let's come back to something smaller. You, a person, on a rock, circling a star, alive for maybe 80 or 90 years, give or take, a blink, a whisper, less than one breath in the lungs of time. And yet, you care. You ask questions. You love. You grieve. You look up. You wonder if any of this, your life, your pain, your joy, means anything in a universe so old, so vast, and so indifferent. Let's sit with that, not avoid it, not numb it. Sit with it. Because what you're feeling right now, this deep pull between smallness and meaning, is the heart of the cosmic perspective. Start with this. Everything you've ever known has happened here, on Earth. Every war, every song, every kiss, every goodbye. This pale blue dot, as Carl Sagan so famously called it, holds the entire history of human feeling. All our gods, all our fears, all our mistakes, all our hopes. And from this tiny stage, we've looked up and asked, what is out there? We've built telescopes. We've sent spacecraft beyond the edge of the solar system. We've detected neutrinos and gravitational waves. We've watched galaxies dance across billions of light years. And we've tried so earnestly to make sense of it all. That's beautiful, not because we're successful, but because we try. You see, the universe doesn't promise meaning. It doesn't hand it to you wrapped in starlight. It offers no guarantee that your life matters. But it does give you something else. The opportunity to make meaning, and that is far more powerful. Because what is meaning, really? It's not something floating in space waiting to be discovered like an exoplanet. Meaning is constructed, cultivated, chosen. It is a relationship between mind and experience, between self and story. You build meaning when you raise a child, when you comfort someone in pain, when you stay up late wondering whether your life has been worth it, and then get up the next day and try again. You build it when you look at the stars and whisper, I was here. But what about suffering? If everything fades, if galaxies go cold and stars die, doesn't that make human pain meaningless too? No, it makes it real, because in a universe where nothing lasts, the fleeting becomes sacred. Your love is valuable because it ends. Your sorrow is profound because it was never guaranteed. Your choices matter because you will not get to make them forever. Transience doesn't cheapen meaning, it gives it weight. Just like a star is beautiful not in spite of its death but because of it. Here's something else to remember. We are not outside the universe, observing it from a safe, detached place. We are the universe made conscious. When you cry over a song, when you feel awe watching a solar eclipse, when you reach for someone in the dark, not knowing if they'll reach back, that is the cosmos reflecting on itself. You are not a bystander in this story. You are the story, told in molecules and memory. Some may ask, what's the point of doing anything if it will all be forgotten? But that's the wrong question. The question is, what kind of person will you choose to be while you are here? Because the stars may not remember you, but the people you love will. The kindness you show, the forgiveness you offer, the wonder you pass down, these ripple outward, and though they may not echo forever, they echo now. And that is enough. The Milky Way does not know it is beautiful, but you do. That's the gift? That, in a galaxy filled with unconscious hydrogen and helium and dark matter, something emerged that could see, that could compose symphonies, that could weep at the fragility of life, that could record the light of distant galaxies just to understand where it came from. You, in the vast quiet, that is not nothing. That is everything. So what do? We stay awake. We hold on to the paradox that we are small and we matter, that the universe will forget us, and still our lives are meaningful, that nothing lasts, and that makes everything precious. We care for the earth. We protect each other. We chase knowledge not for power, but for clarity. We fall in love with ideas, with people, with moments. We endure, we hope, and sometimes, late at night, we step outside, look up, and let the silence answer back. You don't need to be the center of the universe to find purpose. You don't need your name written in stars. You don't need eternity. You just need now, this breath, this moment, this chance to be alive while the stars still shine. How galaxies hold their histories. How atoms remember the fire they were forged in. And how you, in your own way, are an archive of ancient light. But for tonight, sleep softly. You are not small in the way you think. You are the light that wonders where it came from. And that is rare enough. We often think of memory as a human thing, a photograph, a journal entry, a scar, a face that lingers behind closed eyes. But what if the universe remembers too? Not in words, not in stories, but in structure, in motion, in pattern. Tonight, let's explore how the cosmos keeps its past, how even in silence, the universe leaves traces of where it's been. Because though the stars may forget your name, the atoms inside you remember the fire they were born in. Let's start with the galaxies. They spin, they shimmer, they stretch their spiral arms like dancers frozen in mid-turn. But look closer, and you'll see scars. Shells of stars, arcing like ripples in a pond. Tidal tails, streams of stars pulled like threads by ancient collisions. Warped disks, off-center cores, rings, gaps. Each of these is a memory, a fossil of past violence. Evidence that galaxies are not pristine. They are survivors. The Milky Way itself bears witness to its past. We see the Sagittarius stream, a faint river of stars trailing across the sky. All that remains of a dwarf galaxy we've been devouring for billions of years. We see clusters that don't quite belong moving differently, chemically unique remnants of long-forgotten mergers. Our galaxy is not a fixed object, it is a palimpsest, a layered canvas of creation, destruction, and rebirth. Now zoom in to the stars. Every star carries its own signature, not just in brightness or color, but in composition. By splitting their light, we see the fingerprints of elements: hydrogen, helium, carbon, oxygen, iron. Each element formed in a different way, in a different place, at a different time. Hydrogen, the firstborn, from the Big Bang. Carbon and oxygen from the hearts of red giants. Iron from the final collapse of massive stars and supernovae. And the rarer elements, gold, platinum, uranium, those come from cataclysmic collisions, neutron stars smashing together, releasing waves of gravitational energy and spewing metals across space. The star you see twinkling tonight may carry traces of one or more of these events. It is not just a point of light, it is a record, a memory of ancient processes. And when that star dies, its memory will continue. The atoms released will be swept into clouds, which will form new stars and new planets, and perhaps one day, new beings that look up and wonder, where did all this come from? Now let's come closer To you, every atom in your body was forged in a star. That's not poetry. It's physics. The iron in your blood was born in a supernova. The calcium in your teeth compressed in the core of a dying star. The carbon in your skin, the product of fusion reactions in ancient suns long gone. You are made of memory. You are a walking archive of the cosmos. But it goes deeper. Your brain, the thing listening to this, thinking, remembering, stores information through patterns of electrical signals and molecular changes. And those processes obey the same physical laws that govern galaxies, the same gravity that shapes orbits, the same electromagnetism that lights stars, is working right now to let you understand this sentence. You are the universe remembering itself, not just chemically, but consciously. And the Earth? It remembers too. The rocks beneath your feet hold timelines etched in strata. Ice cores trap bubbles of ancient air. Tree rings count the years like quiet historians. The magnetic field shifts over millennia, leaving fingerprints in cooled lava flows. Fossils speak of vanished creatures. Genetic code records lineages billions of years deep. This planet is not just a home, it is a library. A place where matter has been keeping notes since the beginning, quietly, steadily, without fanfare. And we clever, fragile minds have only just begun to read it. But memory is not only in matter, it is in motion. The orbits of planets, the trajectories of comets, the slow drift of continents, the wobble of the Earth's axis, the dance of stars through the galactic disk. Every movement reflects a cause, and every cause is rooted in a past. Physics, at its heart, is the study of how memory unfolds, how systems evolve based on where they've been. Entropy, even in its slow, inevitable rise, is a form of record keeping. When an egg breaks, when a fire burns, when a galaxy spins, each transformation leaves the universe slightly changed, and that change can be measured. That change is memory. And so we ask, does the universe forget? Maybe. Eventually, black holes evaporate, stars die, galaxies fade. Even protons may decay. Over vast timescales, the structure dissolves. But even then, while it lasts, each structure holds a whisper of before. And as long as someone remembers, as long as someone asks, as long as someone looks up, then the story continues. Not because it was recorded perfectly, but because it matters. So what is your role in this? You are a keeper of memory, not just of personal stories, but of the cosmos itself. When you teach a child what a star is, when you write about the universe, when you pause in silence beneath the night sky, you are participating in the oldest ritual there is. You are remembering forward. You are passing on what was learned not to preserve the past, but to ignite the future. Because knowledge is not just for knowing, it is for becoming. What happens when everything ends? When even memory fades? Is there such a thing as a final truth? Or do we carry meaning only for as long as there are minds to hold it? But for tonight, rest. The stars are not just light, they are stories, and you are made of both. Sleep gently. You are how the universe remembers it was once alive. We've journeyed through stars, galaxies, voids, and time. We've watched the Milky Way form, merge, flare, and fade. We've seen how the universe remembers through structure, motion, and light. But now, we arrive at a deeper horizon, not one of distance, not one of time, but of meaning, because eventually, everything fades. Not in a single moment, but slowly, relentlessly, inevitably. We've already glimpsed the long future. The stars will burn out. The galaxies will go dark. The black holes will evaporate. The cosmic web will unravel. Photons will stretch beyond usability. Protons, if they decay, will crumble into nothing. What's left is the black era, an age beyond imagination, trillions of trillions of trillions of years into the future, an era where the universe is cold, empty, and quiet. No stars, no heat, no thought, just drifting particles in a space that never stops growing. And here's the question. Is that the end? Is there such a thing as finality in a universe where time keeps ticking even when nothing remains to measure it? It's hard to say, because even nothing is still something. Even silence is a state. The universe, in its emptiness, still exists. But is existence without structure meaningful? That's a question only a mind can ask. And by then, there will be no minds left to wonder. That silence is not just quiet, it is the absence of curiosity. So, why does this matter now? Because we live in the opposite moment. Now is the age of fire and form. Now is when the universe is alive with light. Now is when stars still speak in photons, when galaxies still dance, when atoms still remember the furnaces that birthed them. Now is when minds exist. And in all the billions of years before, and possibly after, this sliver of time is the only moment the universe will know itself. That makes now sacred, not because it's permanent, but because it isn't. This is the paradox of cosmic existence. You are temporary. Everything you love will vanish. Everything you build will fade. Everything you understand will eventually be forgotten. And yet, you have the ability to witness, to feel, to connect, to create meaning where none was guaranteed. That is not trivial. That is everything. The silence that comes after the stars die is not a punishment. It is simply the final act in a long and beautiful story, a story that began with quantum fluctuations in a seething vacuum. That grew into galaxies. That made stars. That made planets. That made life. That made consciousness. That made you. The silence is just the page that follows the epilogue. But here's something to hold on to. What if meaning is not about permanence? What if it's about intensity? A nova lasts mere days, but it lights up the galaxy. A thought lasts only seconds, but it can change the course of a life. A species may vanish, but its voice can echo across the stars. You don't need forever. You just need to shine once. The universe is not cruel. It is indifferent, and yet it produced beings who care. That may be the greatest mystery of all. That matter, left alone long enough, begins to question its own existence. That particles, arranged in just the right way, feel love and loss. That hydrogen atoms, after 13 billion years of fusion and gravity, wrote poetry and wept over sunsets. That is not just rare, that is miraculous. And yet it happened, here, now, to you. So how do we face the silence? By listening to it, not with fear, but with reverence. Not by turning away, but by leaning in. By understanding that impermanence is not the enemy of value, it is the source of it. Because what is more beautiful? A star that never dies? Or a star that flares with impossible brightness for a moment, then quietly returns its elements to the void? You are that star. You burn for a short time, but your light reaches others. And that light does not vanish. It travels, sometimes for years, sometimes for generations, sometimes forever. There will be no final observer, no cosmic librarian closing the book, no voice reading the last word aloud. But perhaps that's the wrong metaphor. Perhaps the universe was never a book. Perhaps it was a song, one that began softly, grew louder, built harmonies of stars and minds, and now fades slowly into the long, low hum of space itself. A song no one finishes, but one that, for a time, was heard. And so we return to you, not as a detached observer of a distant galaxy, but as a note in that song. You were not born to last forever. You were born to resonate, to feel, to wonder, to be. And in doing so, you added something to the universe it did not have before. Awareness, not as a number or a location or a set of coordinates, but as a feeling. We'll close with the paradox that started it all, that we live in a galaxy that is both immense and invisible, ancient and new, vast beyond understanding, and yet intimate, because it is our home. But for now, rest. The silence is not empty. It is full of all the things that once were, and the echo of everything that tried to understand them. Sleep well. The stars are quiet now, but you are still here, and that is more than enough. We end where we began, beneath a sky filled with stars, with a soft streak of light arcing above the horizon, quiet, constant, waiting. The Milky Way, a name that sounds almost too gentle for what it truly is. A swirling structure more than 100,000 light years across, spinning stars like sparks, carrying you on an orbit that takes over 200 million years to complete. And yet, here it is, just a pale band across the night sky, soft enough to miss, beautiful enough to stay. You know more about it now. You know it's one of hundreds of billions, perhaps trillions of galaxies, that it sits on a filament of dark matter, that it's been shaped by collisions, mergers, and tides invisible to the naked eye, that it remembers its past in streams of stars and warped arms, that it contains not just suns and gas, but a fragile, thinking species capable of asking, "What is this? Where are we?" You've seen where it fits, not at the center of the universe, not at the edge of anything, but suspended like all galaxies in the expanding space between all others, neither special nor ordinary, a paradox of scale and meaning. And through that paradox, you've walked. But the most surprising part? It's not the size, not the age, not the number of stars, or the swirl of arms, or the black hole at the core. It's the intimacy, because now, after everything, after part I through part xi, you are no longer standing beneath the Milky Way. You are inside it. And more than that, you are of it. The atoms in your blood once swam in the spiral arms. The calcium in your bones cooled in the heart of a long dead star. The oxygen in your lungs formed in waves of stellar birth across this very disk. You are not just on a journey through the galaxy. You are a part of its structure. You are the Milky Way, in one of its rare conscious configurations. A momentary flare of awareness rising from its matter, asking where it came from, asking what it is. And that is what makes this final chapter different. Because it is not about distance, not about darkness, not even about death. It is about home. So, what is a galaxy, really? Not just stars, not just gas and dust. It's a system, a story, a stage where elements cycle and evolve, where energy flows, where entropy dances with form for billions of years before letting go. It is, in every way that matters, a process, and that includes you. You are not fixed, not finished. You are changing, orbiting, learning, decaying, rebuilding just like the stars. You are not separate from the Milky Way. You are what happens inside it. You are its thought, its voice, its witness. Somewhere, on the far edge of the galactic disk, a star is being born right now. Its light will take hundreds of years to reach us. By the time it becomes visible, you will be gone. But someone else might see it, and they might feel what you feel now, that ache, that wonder, that gravity of scale tugging at your chest. And in that feeling, you are connected, not just to the stars, but to every mind that ever looked up and asked, "Where am I?" So, what have we really learned? That the universe is vast? Yes. That it's cold? Often. That it doesn't revolve around us? Absolutely. But also, that stars die to make life. That silence can be beautiful. That light carries stories. That meaning can be made, even when nothing is guaranteed. And most importantly, that knowledge doesn't shrink wonder, it deepens it. The more we know, the more impossible it feels. And yet, we keep asking, not because we think we'll reach the edge, but because the asking itself is the gift. The Milky Way is not a destination, it is a frame, a way of seeing your life against something vast, not to make you feel small, but to show you that your brief existence is part of something continuous, generative, mysterious. You came from stars. You will return to stars. In between, you get to wonder. You get to love. You get to make music and cry in the dark and touch someone's hand and feel them squeeze back. And if that isn't cosmic, what is? So, this is the end. Not of the galaxy, not of the universe, but of this journey. We began with a question. How big is the Milky Way? And now we see it is not just big in size. It is big in implication. It is big in the way it holds all the conditions for thought, for love, for awe. It is big in the way it contains you, and yet asks nothing of you. It just is. Spinning, shining, waiting. Tonight, if the sky is clear, go outside. Find a dark place. Let your eyes adjust. And when you see that faint, silvery band, remember, you are not looking at something far away. You are looking through something you belong to. A structure of stars, a memory of collisions, a cradle of consciousness, a galaxy that doesn't know you're here, but gave you everything. Thank you for walking this far, for listening, for asking, for being, for a moment, the part of the Milky Way that looked back at itself and said, I see you. Sleep well, traveler. Your orbit is gentle, your starlight is ancient, your questions are sacred, and this galaxy is yours.